Good morning, everyone. Thanks for being here today on the joint Coastal Beach Water Quality Workgroup meeting. We have a great agenda that we have for you. I have a few announcements during the introduction period, and then we'll do just a brief roll call before we get into the presentations. Today's meeting is being recorded, and we hope to post that soon after the meeting. We'll send out an email to the listservs about when the recording is posted. So please sign yourself up for the listservs for both the Northern and Southern Coastal Beach Water Quality Workgroups if you're not already receiving these emails. The instructions on how to do so is on the second page of the agenda that you received for today's meeting. And you can also unsubscribe yourself at any time following the same instructions. An announcement about the users of Beach Watch. We had an update for the program last weekend, and we had some technical difficulties and experienced some data corruption. So for all of the grantees, please review the data that you submitted to Beach Watch during the week of March 8th through March 12th. This was last week. And confirm that it's all been submitted. And please email me if you do see it there. If it's not showing up, please resubmit this data and then also email me that it was not shown and that you've resubmitted the data. We're trying to determine how widespread the problem is, and we want to make sure that everything is recorded in Beach Watch properly. And we apologize for any inconvenience. Thank you for that. And quickly, we have a message from Catherine Walsh on the Coal Alert 18 and testing method concerns.
Hi, can everyone hear me?
Yes.
All right, so this will probably be pretty relevant to an item that's coming up later on the agenda. But we just wanted to let you guys know that we are coordinating with ELAP we in DWQ are coordinating with ELAP to consider alternative approaches to address the challenges and concerns that have been raised regarding bacteria testing methods and requirements for this program over the past, I don't know, I guess it's been a couple of years now. And we recognize both the benefits of having cost-effective and rapid detection methods, as well as the limitations of some of the US EPA-approved test methods for this program. But with that in mind, there are regulatory requirements for this monitoring program that need to be considered, specifically the bacteriological standards set forth in Section 7958 of Title 17 of the California Code of Regulations, which limits the indicators that are monitored to total coliform, fecal coliform, and enterococcus, and requires that laboratories that perform these analyses are ELAP certified for microbiology methods for that sample type of ambient waters. In the interim, we understand that some local agencies and laboratories may not be able to meet these regulatory requirements. But in the long term, we may request that local agencies and laboratories make changes or take action to ensure that appropriate test methods are used and that laboratories performing the analyses are ELAP accredited for those methods. However, should we request such a change, we would provide ample time to adjust accordingly. I do want to share that we are working with ELAP to provide a guidance document to local laboratories, and we'll be gearing up to work on that a little bit more this coming year. And we will continue to engage with local agencies and laboratories as we consider solutions to these challenges, and we'll be looking for opportunities to continue to provide support. And that's all I wanted to share. I'm happy to answer any questions now or later or offline.
Great, thank you, Kat. Yeah, so if anyone else has additional questions related to that, feel free to email me. This is Karen Black, and I can direct those to Kat if necessary. So for introductions and our roll call, I only need one person from each agency to announce themselves. I'm just going to check off for the entire agency that you're present. And after the presentations, we'll take questions for each one. And at that time, you can please reintroduce yourself if you haven't spoken already, and your agency affiliation. For those of you who are listening online and aren't able to verbally ask questions through Zoom, it will be a little difficult for me to both facilitate the meeting and take questions or comments via email, but feel free to do so, and I will try to check them throughout the meeting. My email is karen.black@waterboards.ca.gov. And again, I'll do my best to address those either during the break or after today's meeting. You can also email the presenters directly if you have questions for them related to their presentations, which is why we have provided their email addresses on the agenda. Now, my name is Karen Black, and I work for the State Water Resources Control Board up in Sacramento. And we heard from Catherine Walsh as well. Do we have anyone else online working from the State Water Board? Now, those of you can individually say your name.
Good morning, this is Jacob Oaxaca. I'm with the State Water Board Division of Drinking Water, ELAP, the Environmental Laboratory Accreditation Program.
Good morning, this is Andrew Hamilton. I'm the QA officer for State Water Board, and I work in the Office of Information Management and Analysis.
Good morning, this is Kira Tuso. I'm in the Division of Water Quality at the State Water Board.
Great, all right. And if you jump on or have difficulty unmuting yourself, feel free to jump in later and mention yourself. Now for the counties, do we have someone from East Bay Parks on the phone?
Yes, we do. Hal McLean, Sabrina Sexton.
Great, thanks. Anyone from Humboldt County? And Marin County? Monterey County? And Mendocino County? San Luis Obispo County? Santa Barbara County? Ventura County?
Good morning, this is Gladys Dobson for Ventura County.
Hi, great, thank you. City of Long Beach? Los Angeles County? Or City of Los Angeles?
So, hi, this is Armando D'Angelo with LA County Public Works Stormwater Quality Division.
Great, thanks for joining us. San Diego County?
Yeah, we have Joseph Palmer and Farnaz Farhang and Dominique Edwards. I think that's it for right now.
Great, thank you. Santa Cruz County and City of Santa Cruz.
Yeah, Matt Basay, City or County of Santa Cruz Water Quality Program.
Jan Babatola, City of Santa Cruz.
Hi, thank you. San Francisco County.
Good morning, Diane O'Donoghue here.
Great, thanks. Orange County or City of Orange.
Joe Guzman with Orange County Public Health.
Great, thanks.
Grant,
Sonoma County.
I'm sorry, Grant Sharp with Orange County Public Works.
Sure, great, thanks, Grant. Sonoma County. San Mateo County. All right, how about any of the regional water quality control boards? Any of the regions, you can go ahead and speak up.
Good morning, Barbara Baginska from Region 2, San Francisco Bay.
Great, thank you. Any other regions?
Helen Yu, this is Helen Yu from Region 9, San Diego.
Hi, Helen.
Hi, Karen.
Thanks. All right, how about any state agencies? Department of Public Health.
Chad Crane, Drinking Water Radiation Branch, California Department of Public Health.
Thank you. Anyone from state parks? Any other cities or local agencies? City of Malibu, City of Orange, any other cities I might have missed? City of San Clemente.
Hello, Laura Sato, City of San Diego.
Great, thank you. How about federal agencies? Oh, sorry, did I hear someone?
I was going to say I was slow to unmute when you called LA, but
right.
Thomas Parker, LA County Sanitation Districts.
Great, thank you. Yeah, I try to wait a little bit. So if you're slow to unmute, that's fine. Just jump in and let me know that you're here. Federal agencies, we have US EPA.
Terry Fleming.
Hi, Terry, thank you.
And one other.
Eric Dubinsky, EPA Region 9.
Great, thanks. Anyone from SCWRP, Southern California Coastal Water Research Project?
Yes, Josh Steele was here.
And universities, anyone from Stanford? And anyone from Sacramento State?
Yes, hi, this is David Alderetti.
Hi, David. Great, thank you. And any other universities that might be on? How about nonprofits? Heal the Bay? Surfrider.
Hi, this is Katie Day, Surfrider Foundation.
Hi, Katie. And anyone from the Bay Foundation? And any other nonprofits that might be on? And last but not least, any consultants? You have NBC Aquatic Sciences, Larry Walker Associates, Weston Solutions, Dudek, Geosyntec, McGowan Consulting, and Wood Environmental. Right, thanks everyone for bearing with me on the list. We like to see who's participated. Anyone else like to announce themselves from an organization that we didn't get to?
This is Stephanie Webb from California Sea Grant.
Oh yes, hi. I should add Sea Grant to my list.
Shayna Rappaport, Colorado River Board of California.
Thanks, Shayna. All right, thanks all so much for bearing with the list. And we will go ahead and get started with the first presentation. So I'm going to stop sharing, and whoever is first on the list, feel free to start sharing.
Good morning. This is Joseph Palmer from the County of San Diego. Hopefully you can hear me and see me? Don't see anybody, so I'm assuming I'm good to go. So I'm going to be speaking to you this morning.
Can't see
Share
your
your screen first. Just make sure we can. There we go. Perfect. Thank you.
Okay. So my name is Joseph Palmer. I'm the Supervising Environmental Health Specialist with the San Diego County Department of Environmental Health and Quality. And one of my programs is San Diego's Beach Water Quality Monitoring Program. And hopefully you can see on screen a pretty simple shot that shows, for those of us who are involved in beach management, the objectives that we have are pretty simple, aren't they? We just have to collect beach water samples and then communicate the water quality to the public. So pretty simple situation, and we need to let people know that there's water quality issues when they're out there. So with San Diego, we have millions of people coming to the beaches, and we have a public health and economic impetus to ensure people get informed when the water's safe and when the high bacteria means it's going to be dangerous to go into the water, you may get sick. But we have a big challenge, and that's what we're going to talk about this morning. So the challenge is that the 3 fecal indicator bacteria groups take time to grow. Multi-tube fermentation analysis can take 48 to 96 hours to get a final result from it. To culture the bacteria and return that final result is approximately 72 hours as an average. So if you went swimming on Saturday of last week, you would be finding out later this afternoon whether the water you swim in was safe. At least in San Diego County in 2019, on the basis of a detailed side-by-side study, we moved from the MTF to CoLalert and EnterAlert. The processing time for EnterAlert and CoLalert is a lot better than the 72 hours of MTF, but it does get us results in 24 hours, but it's still a long time. And the lab analysis delay still means that if you went swimming yesterday, you still wouldn't find out till this afternoon what the water looked like. I don't know what the other areas of California are like, but for San Diego, we have about 50% of our bacterial advisories that are only for 1 day. So for half of our advisories, you may have gone to the beach yesterday, saw no warning signs and went swimming. The sample taken yesterday is reported today in exceedance, so the county posts a warning sign and resamples. You go to the beach today, you see a warning sign and you don't go swimming because of that, but the sample results tomorrow show that it was safe. So this is like the conundrum, isn't it? That we have this delay, and it's led to some frustration and some humorous ways to express the problem. So you may have seen a sign, something like this, and yet some people have put together another sign which speaks more clearly to what the actualities are, and that is that the ocean water quality was bad yesterday, and you shouldn't have swum then, and also that the water quality might be okay today, even though there's a sign up. Please check our website tomorrow. And this is the situation that we have faced all over the world, really, for the delay in the culture methods that we're using currently. So San Diego County has set up some study goals that we wanted to address this issue with. So to identify a rapid indicator that didn't last 1 or 2 or 3 days to get final results from, we wanted to have a single water quality indicator instead of the current 3. We wanted the flexibility to use the rapid indicator throughout our entire coastline and not limit it to one particular area. And the theory was we wanted to implement this rapid test by 2019. Obviously that bit hasn't been achieved. And so the answer, we thought, and we still do, is that we could use PCR, polymerase chain reaction. A rapid molecular method was suggested as a possible alternative in 2012 by Keith Keyser, who was formerly in my position in San Diego. This morning, Chad, Josh, and I will speak on the latest science and policy efforts to leverage rapid PCR technology for local beach water testing. PCR works by quickly reproducing DNA in the lab instead of waiting for bacteria to grow. a lag time of hours for PCR molecular method instead of days for the culture methods like PCR, like Enteralert. This is my version of simplifying in my head what's going on. You have a DNA chain, you split it, and the two strands of DNA are then reformulated with spare bits that are in there. I'm sure Chad and Josh can speak to it in a lot more detail, but essentially that's what's going on. And you repeatedly do that until you get enough of the DNA to give you a clear marker. In 2012, Qpcr and colleagues started evaluating the potential for a particular flavor of PCR, Qpcr, quantitative PCR. And in 2013, a small-scale study identified too much variability of the data to be useful in San Diego. It seems that the particular issue with Qpcr, it worked great when there was high concentrations, but at low concentrations, it was too vague. In 2014, San Diego County sponsored legislation, State Bill 1395 by Marty Block, that allows PCR to be used as a water sampling methodology if it can be demonstrated to the US EPA that it provides equivalent results to existing approved methods. And this piece of legislation, combined with some excellent moves in the PCR world, helps us to move forward. So ddPCR, Droplet Digital PCR, became available, and it was able to address the Achilles heel of Qpcr, which is the variability at low concentrations. By 2017, it was apparent that a large-scale study was needed. With limited county resources, the Department of Environmental Health established partnerships with the county's public health laboratory, the California Department of Public Health, and this got also from support from Qpcr to implement the study. The study was designed to compare a droplet digital PCR method with the current Enteralert testing we use to enumerate Enterococcus bacteria in coastal waters. We also brought in expertise from the University of California, San Diego, and the Southern California Coastal Water Research Project, which Josh is representing, Qpcr, to provide statistical and academic support, which resulted in a final research manuscript that has just been accepted for publication in a peer-reviewed journal. Today, we'd like to share the exciting results of this study. Now, Chad's going to get into more detail, but I wanted to give a highlight of just a few items from the perspective of a beach manager. So we had one full-time and one intermittent sampler, and we're able to collect over 3,000 samples from 51 beaches across San Diego's 70 miles of coastline. We did this at least weekly from March 2017 through January 2019, and we covered both wet and dry weather. One of the challenges was that we got too good of results, and so our concentrations were so low that if there was nothing there, you can't really compare 0 with 0. The beach locations were diverse, and we included beaches which were near lagoon mouths, rivers, creeks, and storm drains. There was also open coastline locations, beaches located within San Diego Bay and Mission Bay, and beaches with treated and untreated sewage impacts. Right down by the border, we have a lot of untreated sewage impacts from Tijuana. The 3,000 samples were analyzed for Enterococcus with Enteralert and ddPCR. DEH collected the samples. We took them to the county's public health lab, who analyzed the samples with Enteralert and then extracted sampled DNA, which they sent to CDPH's lab in Richmond to perform the ddPCR analysis. So I wanted to highlight a very important factor, and that is the importance of support and collaboration. This would have been completely unable to be done if it wasn't for the executive and political support that we got in San Diego County, plus the collaboration with colleagues in Public Health Lab, CDPH, Qpcr, and EPA. So now I'll hand over to Chad for a detailed look at the study.
Thank you, Joseph. Okay, I'm going to share my screen. Can you see that?
Yes, just go ahead and put it in the presentation mode.
Okay.
There we go, perfect.
I'm going to move this box out of my way that you guys can't see, but I can. All right, so as Joseph, I'll continue on with what Joseph said. I'm using the same title as his second to last slide, is application of Droplet digital PCR and coastal water quality monitoring, which is also the same title we use for our talk. And this was, as Joseph mentioned, a joint collaboration primarily with CDPH and the County of San Diego, but also other counterparts were brought in to assist with the development and analysis, which included UC San Diego, US EPA, SQRP, and others. So thank you. I'm trying to see if I have this header bar that covers all of my titles, which is really difficult to see my titles on my slides, but I'll do my best. So the County of San Diego, just a little bit of background that Joseph covers, it included the entire San Diego County coastline, which was comprised of 51 sample locations from diverse beaches, all routine sample locations, which are part of the AB 411 monitoring. It included both wet weather and dry weather sampling to kind of encompass all the different variability of conditions that you would see within a sampling campaign. There was over 3,000 samples collected. It spanned over nearly 2 years of sampling on a weekly basis, and samples are analyzed with Enterococcus for enumeration. And there was a variety of statistical comparisons, primarily between Enteralert and Droplet digital PCR and Qpcr and ddPCR, where Qpcr as the EPA approved method served as a sort of quality control check on Droplet digital, the Droplet digital method. The size of the study, as Joseph alluded to, required a lot of collaboration between the County of San Diego, environmental health, as well as their public health departments, CDPH, SQRP, US EPA, et cetera. Quite a bit of people contributed to kind of make this all work and come to a final format that resulted in the manuscript that we submitted. The main methods that were used for comparison were the chromogenic substrate Enteralert, which is used for identifying culturable Enterococcus by generating results in MPN per 100 mLs. The Droplet digital PCR developed by and validated by Biorad and further expanded on by SQRP with a variety of studies that they've published. And the US EPA approved method 1609.1, the latest version, which is their Qpcr method, which we used for a set of split samples. So just to kind of go over how the SB 1395 legislation allowed for PCR-based methods to be used in place of the culture-based methods. And so what, as people know currently, is that bacteria are present in the water, and the individual cells are measured through a series of different experiments, which Joseph went over. And after about 24 to 96 hours, you get the results from the methods, which are at a minimum at least a day late or a day delayed, saying you should not have swam yesterday. The PCR method allows for a little bit more robust and expedited analysis, whereas Joseph showed or demonstrated in his little chunks of pieces. It's a little piece of DNA from the genome of the bacteria, which is basically targeted. These are ribosomal genomic markers, which isn't really important, but what is important is that they're highly conserved across species so that you can identify very accurately which species is present in a water column. And this is by engineering a series of DNA probes and primers, which allow for the amplification of this gene or this segment of the gene over and over again. And so the presence of this allele within the water column that is extracted from this bacterial cell will then undergo this kinetic enzymatic reaction, which is modeled to this equation, which is just an exponential growth of 2 gene copies for every cycle. And after about 4 to 6 hours, you can get your results from the PCR methods and use directly for reporting. So that time savings is quite critical and what was the basis for drafting the legislation 1395. After 1395 was drafted and promulgated into the state register, a new method came out, as Joseph also alluded to, which is a droplet digital format. And the way these look are very similar in terms of their enzymatic kinetics as a reaction, amplifying the gene product of interest. But it's more the format and, that they're put in under for quantifying the gene target. In quantitative PCR, the gene of interest is just thrown into the bulk fluid, and the enzyme reaction cocktail is amplified, similar to as you see in this tube on the left. This amplification allows for exposure of the enzymes and other components or reagents within that reaction that are susceptible to inhibition, and also leads to less sensitivity. And this is illustrated here as you get this amplification ramping up of the gene target. You have this baseline that you must kind of overcome in order to get to exponential growth being particularly important for getting to quantitative results. Conversely, Droplet Digital PCR takes these bulk fluid and partitions it into tens of thousands of droplets. And those tens of thousands of droplets are illustrated here in this column, where you have the droplets in green are targets where there's positive gene target amplified in that tiny little droplet. And the clear ones are droplets where there is no signal whatsoever. And this is kind of amplified here in this little cluster where these green targets would be positive, clear would be negative. And from there you could identify through endpoint PCR. It analyzes it through a Poisson's distribution, the incidence of positive and negative, and allows you to quantify the results through endpoint rather than through endpoint analysis rather than exponential growth. And that allows for the baseline to be taken way down, which allows it to be much more amenable for monitoring applications such as the one we did for San Diego County. The advantages of these, as mentioned earlier, is that it's not sensitive to environmental inhibitors because essentially those compounds are being diluted out through this partitioning, physical partitioning of the sample. And there's no requirement for quantitative DNA standards, unlike the Qpcr method, which could introduce a source of variability unless there is a designated manufacturer or supplier of those that everyone could use. So by eliminating that, you eliminate another area of potential variability. And the endpoint modeling, as I mentioned also, is that this leads to a very lower limit of quantification. So, and I'll give you some of the details of what we discovered from our study results later on that. For the data analysis, we use the EPA site-specific alternative recreational criteria, technical service support materials for alternative indicators and methods. That's quite a mouthful. But ultimately, it provided a nice it served as a nice guidance document for how we were going to compile the data and analyze it. And we used their primary measurement, our model parameter called the index of agreement, statistical parameter, which we incorporated as the primary measurement of equivalence between EnterAlert and Droplet Digital PCR. It requires log transformation steps to put these on sort of more of a normalized distribution, and then incorporation of the index of agreement calculation. The results, ultimately, you have to have, as Joseph said, we had a lot of 0 to 0 comparisons, or I should say correctly, a lot of Droplet Digital positive samples that we could see, but those did not fall in the limits of quantification of EnterAlert. So EnterAlert was really the limiting method in this study. So it was a challenge to get this 30 measurable samples between both methods so that we could fairly compare them. That's a criteria of the site-specific method or site-specific approach. By US EPA standards, the index of agreement greater than 0.7 threshold indicates method equivalence. In the study, we also incorporated Pearson's correlation coefficient, or R, which is used as a secondary parameter or a second line of evidence to support the level of equivalence to model this relationship. Pearson's R being that it's chiefly used for measuring quantities of continuous data sets between methods. And so rather than comparing models. So as Interalert was used as sort of the reference comparator, that was a convenient model to use to compare it to the new data generated through Droplet digital PCR. So initially when we went into this, we had some study questions, like we wanted to get 3 things out of this, or at least be able to answer yes or no. How well does the Droplet digital PCR 23S ribosomal DNA copy number correlate with Interalert MPN when both tests have results within the limit of quantification? For Interalert, that being greater than 10 or less than 2005 MPN cells per 100 milliliters. How do these data sets correlate? What kind of scaling would be required? Distribution of the data, what do they look like as raw data sets and following log transformation, which is required for the site-specific criteria? And what is the outcome of the results in the index of agreement calculation and Pearson's R correlation, which are 2 different models that measure levels of equivalence between the data sets. The second question was, the training subset of data, so I'll get into what the training subset of data, which it was a subset of the total data package of Qpcr and ddPCR split samples, serve as a representative data set to derive an intrinsic copy number equation, or ICE, to evaluate the molecular and culture-based readouts across a larger test set of 3,000 samples. Or in this case, we had to pare it down because we didn't have paired sample results, but I'll show you those details later. And lastly, can DNA copy number be used as an alternative indicator for the detection of actionable Interalert levels? The California single sample alert level, or a measurement being 104 MPN per 100 mLs. So those are the 3 main questions we went into this while we were conducting the study. The way we did this to make it more digestible and feasible to achieve those 30 measurable samples is we took the 51 sample sites up and down the coast of San Diego, California. And this is a figure from our paper. And we kind of distilled this down, or aggregated these into comparable, similar sites of similar environmental and characteristics and water quality characteristics. Particularly open coast or urban impacted areas, or areas that have had historical data that they could pull from in the Tijuana River mouth and Mission Bay in the South County. So these were, or Imperial Beach, sorry. These were all clustered together so that we could aggregate these into individual beach groupings and then take the overall combined across 51 sample locations. This is a figure, a flow chart that summarizes the data processing, basically taking 3,023 samples that we ended up with, and then through the process of culling, because we had missing data points or many samples that fell outside of the limit of quantification. We ended up with the 361 ddPCR Qpcr comparison, which was used to derive the ICE equation and used to scale 193 samples, which resulted in essentially 1,086 out of the original 3,000, because there were so many zeros or non-detects. So it's just a forewarning for people that if you do conduct a similar study, you will get a number of samples that will be out below the limit of quantification. And that's just part of the nature of dealing with environmental samples from beaches in coastal California. So a way to illustrate this a little better is that the training set, which was a set taken from a set of split samples from the larger set, and analyzed separately. And originally there were 361 samples, and that was after removing ones that had failed to produce results or had indicated signs of inhibition that was we identified through Qpcr analysis, and ones that had paired enter alert results. So we had a large sample set of Droplet digital, PCR paired sample results, and a smaller paired sample result subset of enter alert that we can compare, and that that distilled it down to 185 samples that had DNA copy number and enter alert. And from there, we conducted, from the PCR, we conducted an index of agreement, Pearson's correlation coefficient analysis, and then and once those achieved the results, or acceptable results, we derive the intrinsic copy number equation for scaling the Droplet digital PCR data of the larger test set, which included a much bigger, these aren't to scale, but the idea is that there was a much larger pool of Droplet digital PCR samples than the enter alert, and but we could only use the ones that had measurable samples in both methods for analyzing and modeling levels of equivalence. And that this shows the 1,086 samples that had both DNA copy number and enter alert data within the limits of quantification for both assays that we could use directly for measurements of equivalent analysis. So looking at the PCR first, since that was used as a representative training set, both PCR methods were skewed in terms of the raw data that was collected, but they all exhibited normal distribution when following log transformation, which is what that step in the analysis is designed to do. And this is very indicative or consistent with what one would expect when collecting environmental samples. And then we put the data set through the index of agreement analysis, and the IA that came up from those was 0.89, which was above the 0.7 threshold set by EPA. So it supported that these were demonstrating a strong agreement between the readouts. Further looking at the linear regression correlation and Pearson's correlation coefficient, the raw data demonstrated a nice linear correlation at, this is obviously more scattered because these are raw numbers, but then when looking at the log transformation or log scale of these, it show a very tight linear correlation, with Droplet digital PCR becoming a little bit more biased as we get into the lower levels, and that's because it has a lower limit of quantification. And the Pearson's correlation coefficient that we generated from this comparison was 0.87 with a very low p-value. So it supported that this was accurate and representative of the behavior of the data. Following up, we wanted to see what kind of limits of quantification out there. That being reported that Droplet digital PCR had a lower LLOQ, and that is in fact what we discovered, that when looking at the copy numbers per microliter or copy numbers per 5 microliter reaction, that in all cases ddPCR had a lower limit of quantification than Qpcr, and then taking that into reporting limits that would be used for enforcement, that was also consistent, or Droplet digital with the extraction used through the BioRad program or BioRad protocol, it would the reporting limit of this method would be 52 copies per 100 milliliters compared to 188 from the Qpcr method. And that's fairly consistent with other published data. But the good news is that, that the estimated error from these analyses were low for both. So it really does support that the data was consistent across the whole entire sample set, and that these numbers are reliable. So now that we had a relationship and a quality control check on the Droplet digital PCR, we wanted to take that data that we generated from the training set and derive some type of scaling factor or a way to put the culture annular culture readouts in the same scale as a PCR. And as everyone knows, in culture methods are actually growing up individual bacterial cells, and then you're getting a quantity per certain volume reporting limit for enteralert being an MPN or most probable number per 100 mLs. But PCR is a little bit different. So culture, because it's measuring gene copy numbers. So just to reiterate what I showed in the PCR slide is that culture and PCR methods measure the same bacterial organism. They are targeting the exact same organism, but they are targeting different target analytes. So the analysis requires scaling to compare the readouts fairly. I'm going to move this box because it's in my way. So ultimately, culture methods measure colony forming units or MPN per 100 mLs. PCR measures gene copy numbers per 100 mLs. But within an individual cell, in terms of ribosomal DNA, you could have anywhere from 4 to 6 gene copies in one bacterium or one bacterial cell. So scaling the data essentially lowers the readout of PCR so that data points can be evaluated for measurements of equivalent. And this is consistent with the Qpcr method published by US EPA, where the approach of taking actual sequence they term this calibrator sequence equivalents to calibrator cell equivalents. So there's a processing step or a mathematical conversion step that the EPA method requires. And this is essentially what we're trying to establish with our own using the Droplet digital format. So in our study, we empirically derived an equation using linear regression analysis from on the raw data. And we defined it as the intrinsic copy number equation from a representative data set or training set and applied it to the larger test data set for scaling. And this type of approach for data analysis is commonly used in epidemiological data analysis. And so what it really does is it takes this PCR readout, which is in terms of individual units, the units aren't agreeable. So the units for PCR are always higher to culture method. And so what this essentially does is following scaling, sorry about that, is that it attenuates the PCR data, so it puts it on the same sort of plane, and it removes this delta difference, which can confound analysis. And it puts it on the same plane so that they can be evaluated fairly for patterns of behavior and modeled correctly within the same realm, meaning that each cell maintains multiple gene copies so that they can't be compared unit per unit. Essentially puts them on as close of comparable units as possible. And what this looks like is, I gotta move this to this side now, because it's linear regression, it just essentially generates an equation of a line. The linear regression was used on the 185 samples that had enteralert values, and the equation that we generated from this was this equation here, y equals 0.06183 times x plus 16.61, where x equals the DNA copy number, y equals MPN from enteralert, following substitution, MPN equals 0.086, which is the scaling factor, DNA copy number to 0.16.6, where the R squared from this equation was 0.38, which is fairly good considering this is environmental data. I've seen epidemiological data with much lower R squared, so anything close to 0.4 is actually quite good. When you rearrange this equation, it allows you to run your estimates for DNA copy number as the equivalence to MPN using this DNA copy number equals MPN minus 16.6 divided by 0.6183. And through this scaling, we applied this scale and to the larger test data set of 1,086 samples that had measurable enteral alert and droplet digital PCR results. And the scaling the test data set using the ICE generates a quantifiable range for direct comparison, that being the enteral alert that we know, which is published by IDEX, which is greater than 10 or less than 2005 MPN per 100 mils. The corresponding scaled reference range for droplet digital PCR would be 107 copy numbers to less than 32, 159 copies per 100 mils. But note that from the previous slide that the actual reporting limit of droplet digital goes even lower. It goes about half that to 52 DNA copies to 100 mils. So this is just putting it on the same scale or range as enteral alert. So looking at the data collected from the large test set, both data sets exhibited sort of a skewed behavior from the raw data set, but then following log transformation, similar to the training set, droplet digital formed a very nice normal distribution, which would be expected from environmental sample set, where enteral alert didn't. It had an enormous number of low detection, non-detects and low detection. The low detection were measurable so they could be used for analysis, but because a large number of samples were from a relatively clean according to the referenced standard method enteral alert, it created a skewed bias mean comparator. So that was created some problems for the analysis, which required some adjustments and further statistical testing to determine, or at least see what was creating this impact, find some observations which were consistent with this behavior. So the significant skewing of enteral alert data towards the low signal results in a bias mean comparator, as I said, and this required reanalysis of the central tendency measurement in the IA equation using the mean to the median to evaluate if the median was more representative of the full data set rather than the mean. In this case, it was, and I'll show you that data in the next slide. In the analysis with log transform and non-transform data for comparison to see if this transformation step was actually impacting the behavior of the data and the downstream analysis or results from the analysis. And what we found is that it was, that the significant skewing was interfering with the final analysis. So we conducted the index of agreement with log transformed and non-transformed data, as well as using the median. And we applied the log transformed and non-transformed data sets to the Pearson's R correlation. And these were all scaled with the ICE equation. And what you see is that when taking log transformed to non-transformed is that you see an improvement across many of the sample, the beach groupings. This was not consistent across all of them, particularly in the ones that were heavily impacted, Tijuana Rivermouth and urban impact areas such as La Jolla. You see that those actually decrease, and that it supports that there was less of a measurement. The equivalence measurement was there was less of an agreement of equivalence of these sites because there was sample-to-sample variability, or in these cases when reviewing the sample set, there was a broad distribution in the samples that we were collecting, which created, which impacted our levels of our analysis, sorry. But in the sample sets, especially in some of the open coast or lagoon areas where you had a distinct signal, you see an improvement. And this was consistent with the Pearson's R calculation, where transformed versus non-transformed data showed an improvement. I mean, non-transformed data showed an improvement from log transformed, suggesting there was a strong impact of skewing from the enteral alert data. In all cases, taking all of the samples that we collected combined through these different analyses resulted in 0.72 for the index of agreement using the different mean or median parameters, or even up to 0.74
looking at the median, and with Pearson's R, looking at log transform versus non-transform, achieved 0.44 to 0.6 final values. So the overall combined data set across the entire county achieved the level of equivalence according to EPA site-specific criteria with the IA equation, and was further supported with the Pearson's R correlation. So these trends and patterns that we see with the data did support that the significant level of skewing from the clean or low detect samples from Ranch Alert did impact the final analysis. So given that we felt that there was a correlation of equivalence between the two methods, we wanted to see how these would work in terms of beach management decisions, in terms of a broader application. So that provided us with a much larger sample set, because we can use samples that were outside of limits of quantification, and we weren't limited by that, because ultimately an inter-alert sample that was less than 10 would likely not be recorded as a positive or an incident requiring posting or beach closure. And conversely, a sample greater than 2005 would likely require posting because there would be some indication of risk. So distilling down the sample sets from the Droplet digital or inter-alert, from excluding the values that either weren't there or were not, or samples that weren't analyzed, we had a combined data set of inter-alert and Droplet digital of a total of 1,993 that we could use for conducting this analysis. The way we did this, we ran a receiver of operation curve, which isn't important in this case, but what it does is it, this percent agreement is a figure from our paper. What essentially we did is we used the current regulatory single sample incident for beach, I should say posting, not closure, of 104 to 100 mLs as the sort of primary measurement for making beach management decisions. And we set that against the Droplet Digital PCR to identify what value of Droplet Digital PCR would correspond to the 104 mpm per 100 ml. And that's what the ROC analysis did. It identified at a point, and then that value came up to be 1,413 ddPCR copy numbers as a cut point, which was the closest estimation to the 104. From that, we constructed a percent agreement curve and followed the trends of increasing ddPCR copy numbers corresponding to the 104 mpm per 100 mLs. And that identified at that ddPCR cut point, we identified an agreement of 90.4% with a false positive rate of 3.7% and false negative rate of 6%, which was consistent with other published studies. So that was encouraging to us that this was, in this study, the samples collected in this study were corresponding as would be predicted in terms of beach management, or how it would be applied in beach management. And this is just a slide. I'm not saying that what we did was equivalent, but this is taken from the US EPA Rec Water Guide from 2012. And they're already considering this sort of this relationship of PCR methods in terms of how it would be implemented as a beach action value. In this case, they came up with a beach action value for culturable enterococci of 70 CFU compared to 1,000 calibrated cell equivalents from Qpcr. And our advisory, if we wanted to extrapolate San Diego's study advisory threshold that we identified as a beach action value, the 104 MPN for enterococcus or from inter-alert will correspond to 1,413 copies from the Droplet digital. And we're not saying that these are equivalent in any way, but it shows that there's somewhat of a consistent
trend in terms of what data points or thresholds are being identified as appropriate. And this likely could be used further for evaluating appropriateness in terms of regulatory applications. So, 1 second. So the study results, overall, the index of agreement that we achieved from all the samples across the county, I achieved a value of 0.72, which is above the US EPA threshold of 0.7. 5 out of the 10 groups yielded acceptable IAs, and all groups yielded IAs greater than 0.6. So it exhibited a tight relationship across all groups and achieved the acceptable threshold across the combined county sample set. Pearson's R results further demonstrated a strong relationship with an overall combined R value of 0.6. Grouping beaches according to similar characteristics allowed for direct comparison for evaluating EPA site-specific criteria, which was essential. Otherwise, we would be stuck with some sample locations yielding nothing but zeros or non-detects. And this satisfied the criteria of generating greater than 30 measurable samples per grouping. And the application of the ICE equation, or intrinsic copy number equation, to scale the two methods is similar to the US EPA approach used for Qpcr. The Droplet digital PCR exhibited a better LLOQ than Qpcr in this study, 52 copies per 100 milliliters versus 189, or that should be 188 per 100 milliliters. But as demonstrated, the estimated error was low for each. So they're both very solid methods. In the comparison of the data, this is important for future studies, is that the PCR data set does exhibit a more normal distribution, unlike EnterAlert, which I think will repeat across different studies. And there are other publications that have demonstrated this. EnterAlert really does have, this issue with having many low positives. And so that makes it difficult for comparing data sets when one is very normally distributed and the other one is biased towards sort of a skewed level. So that needs to be considered and dealt with during the analysis of the data. The significant data skewing was noticeably impacted by log transformation and affected final results of the IA and Pearson. So that is something to consider when evaluating the data. The ddPCR alert level of 1413 copies is correlated with the EnterAlert MPN, or EnterAlert 104 MPN per 100 mil 90.4% of the time. So it showed a very tight relationship in terms of beach management FIB exceedances. From this study, we presented the data and our study results to US EPA Region 9, which approved ddPCR for beach water quality monitoring in San Diego County as a pilot program. So that's something that this is the next steps of the project, trying to get this fully implemented in San Diego County for AB 411 monitoring. And we further believe that the study provides a nice framework for other counties in California to implement PCR-based monitoring. So the equations and the reference values will serve as nice tools and guidance for other people trying to conduct similar types of analysis and evaluations from the method. So the study conclusions, this goes back to the original questions we asked. Does the Droplet digital PCR 23S rDNA copy number correlate with EnterAlert MPN when both methods have results within the limits of quantification? Thus being the EnterAlert, the reference comparator of greater than 10 and less than 2005. And what we came up with is the IC scale ddPCR readout aligned closely with EnterAlert MPN for identifying FIB exceedance levels of Enterococcus in the study based on the IA and Pearson's R model correlations. So there are two lines of evidence that supported that there was a significant level of equivalence between the two methods. The second question is, did the training subset from Qpcr and ddPCR split sample serve as a representative data set to derive the intrinsic copy number equation that was used to scale the molecular and culture-based readouts across a larger data set? Well, the PCR methods were highly correlative, and that wasn't a surprise, but it was a great quality control check on the overall data package. Both model parameters, IA and Pearson's correlation, or Pearson's R, exhibited significant levels of equivalence for the PCR methods and with entry alert following scaling with ICE. The outcome suggested the training subset was representative of the larger data set and appropriate for deriving the ICE equation, or the ICE, sorry. The last question that we had was DNA copy number a reliable alternative indicator for detection of actionable entry alert levels, single sample exceedance level being 104 mpm per 100 ml. Well, what we found is that the estimated equivalent to the 104 mpm, which is 1,413 DNA copy numbers, correlated 90.4% of the times as entry alert, and had a level of false positive and false negative rates similar to other culture-based studies. And Josh can go into that. I think we'll go into that in more detail later. And this suggests that DNA copy number did serve as a reliable alternative indicator for actionable FIB levels in this study. So that's it for the presentation of the study, but I just wanted to display this final acknowledgement slides to the entire group. This was a very nice collaboration. I thank all the members who participated. I would particularly like to highlight Marva Seifert, Professor Marva Seifert from UC San Diego, who conducted this data programming for the data analysis. She was very tolerant and patient with every single step of the analysis and changes I wanted to evaluate. And I think through all of that effort, a combined effort, it was quite fruitful, the final results. And then also highlight Keith Kieser, who initially reached out to CDPH with the idea of conducting such a study 3 years ago now. So thank you all. And now I will hand this off to Josh.
All right, thanks, Chad. Here, I'm gonna share my screen now. So can everybody see it?
Yes, we can see it.
Yes.
Go ahead and full screen. There you go.
Okay, full screen. Here we go. So, I mean, thanks, Chad. What I'm going to do now is sort of put it into some context, this study into some context, and also sort of talk about some future directions and some exciting things we might do next, or even in the more distant future, some exciting things that'll come along to improve things or make them that much better. So, I mean, one way to think about it is that this study is showing an improvement on a viable, rapid method. This gives not only something that's relatively fast, certainly faster compared to culture methods, but also is a solution to the problem we have in California waters of we have diffuse pollution sources, and a lot of the time our water is just too clean for these methods to be able to correlate. Implementing this method in San Diego is going to allow us to further refine this with the pilot project and increase the rapidity of the method and the analysis for faster public protection. And then finally, in sort of the longer term, we're thinking the next step, the immediate next steps is to expand this type of study, this type of comparison to other locations, and then add further improvements in techniques. And I'm going to quickly go through all of these. I know you guys have been listening for a long time. I promise I will do it as quickly as I can. There we go. Oh, there we go. Okay, so what do I mean by sort of improvement of rapid methods for waters with diffuse sources? As you all are well aware, California has a lot of beaches with lower diffuse pollution sources. This provides, as Chad and Joseph described, sort of mismatched ranges of quantifications in the methods. And this can reduce our ability to compare them. Digital PCR provides one potential solution to this problem because it has a lower limit of detection compared to Qpcr. So maybe we can get more samples where we can compare in that lower range. But there's other potential solutions too, such as switching to a gene-based target instead of comparing culture to Qpcr. There's good and bad with both of those. So what do I mean by we have, this wide range and method variability in California waters? Well, for this study, we had an overall R squared of about 0.6 for all the samples, but the range of those different site groups ranged from 0.13 to 0.94. Those were the different R squared values that we found. This is normal. When we looked in the Byte 13 study, there were a few digital PCR versus culture comparisons, and they ranged from 0.01, so very low R squared, to 0.74. And if you look at Qpcr versus the culture methods, it's a similar range to the digital PCR, so not a big surprise. And then even when you look at culture to culture methods, we're in some of that same range too. They're not as variable, but they certainly are variable, especially in these waters, which is different from some of the other studies where you have a point source like a sewage outfall right at the beach. So what are our options for dealing with this? Well, this provides one where we can do digital PCR compared to culture, digital PCR compared to Qpcr. And you can see on the left that if we were comparing the Qpcr and digital PCR, comparing a gene-based method to another gene-based method, we have a pretty nice R squared, 0.76, very similar to when we're comparing culture methods. Similarly, if we look not just at beach water, which is what we looked at in this study, but when we looked at stormwater discharge and the Surfer Health study in San Diego, we also got a very reasonable correlation between digital PCR and one of the culture methods. So there are some options to explore if you can't get the beach samples, but these would be things that would have to be discussed with the regulators too, to make sure that you could come to an agreement on how to interpret these from a management perspective and to protect public health. But these are just some other things to keep in mind that this opens up potentially. Sort of the next phase is implementing this pilot project in San Diego, and this is going to allow for the public to get same-day beach water quality data. And we've done, SQURP in particular has done some of this before in other pilot projects in Orange County and elsewhere, where we tried to, it was probably about 10 years ago, where they tried to get the samples and have by noon the same day water quality information shared with the public. Now, the way they did it then was at Doheny State Beach. So there's a place everyone has to come through and the ranger station here, and they had a screen that you can see up here, and I'll zoom in for it. And you could get today's water quality. It would tell you when it was updated, what the date was. And so samples collected that morning, you had results to share with people. Now, this is great, and this is something that could be implemented where there are signs at the beaches that are updated on the same day. But as Joseph showed you, we also, San Diego in particular, and the other beaches too, they have a phone-based or app-based system, so people could check their phones on the same day. And ideally, this would be in time that, by the afternoon when a lot of people are arriving at the beach, especially in the summer, they would have that information. The other next steps is, as they're doing this implementation, that they'll be able to sort of refine the technique, make it faster, and standardize it in a way that can be shared with other labs. And this will provide opportunities for transferring the technology and also informing accreditation of the labs to be able to run these types of methods in California and elsewhere. So in the in the longer run, where we see this going is that we'll have to, EPA has approved this for a pilot project in San Diego, but we need to expand this and test it at other beaches. So that's probably the immediate next step, is trying to find other places where this method can be tested and compared against the culture methods and the regulatory methods that exist now. Another future direction is the addition of other targets, because the good thing about the gene-based technique is you can take that same sample and measure more than one thing in it at a time with little marginal cost in time or money. And finally, in the long run, innovations in sampling and assays will speed things up, both from a sample collection standpoint and from an analysis and results standpoint. And so I'm going to quickly skip those. But what I'm talking about here is, side-by-side comparisons with culture methods are going to be required for the implementation of these gene-based methods. So interlaboratory comparisons, method evaluations among different public health agencies, different beach managers, that's going to be probably the next step and the fastest way to move this forward. And we could add new targets to assay that would provide more information. One of the last times we did a giant method evaluation study was just about 10 years ago. And all I want you to take from this really large table before your eyes glaze over is that there is no digital PCR on this table anywhere. So there's definitely Qpcr was evaluated, culture methods were evaluated, digital PCR was for the most part not evaluated. And in the long run, things to increase sample speed and time is basically automation. We've been working in the past with folks at Mbari, engineers and scientists to develop their next generation of environmental sample processor, which is right here, the size of a tackle box that can take a water sample, and basically it takes a water sample in and then it spits out DNA that's ready to go for analysis. And it could, in theory, do it while the samplers are collecting water. They could take a water sample and have it starting to be processed and ready to go while they're connecting the next one. And then there are improvements in automating and miniaturizing digital PCR, sort of lab on a chip, where you might be able to get, again, the results sort of in real time as they're collecting more samples. This is not something that's happening, next week, but it is something that we would look forward to. And now I'm going to pass it back to Joseph. Joseph, you're muted.
It's funny, you have to click unmute twice. So thanks for that, Chad and Josh. That's really interesting stuff. And hopefully everybody sees the potential that we've got going on here for San Diego, at least, and the potential that we could have for everybody to be on the same page. But I wanted to go back to our initial problem, which was the 24-hour delay, and have a look at that, because have we answered the question? So the lag time was the problem. And when we come back to that situation, did we address our study goals? So you do see that 3 of our 4 study goals were addressed already. And then the implementation phase, which I'm very impatient to get going, has dragged on since 2019. So there's a few more steps that need to be covered. And here's where we're at right now. We hope for state approval in the next fiscal year and that we can get this going. From a beach manager's perspective, what this means is that we're going to want to have our samplers out in the field earlier in the day and probably have more of them. So shorter runs by more people to get the data as early as possible to the beachgoers. Based on what Josh was looking at, I'd love it if we had an automated buoy system that was just constant. That would be a way to look at it for the future, which would be awesome. What we have achieved really with this is to demonstrate that we can lift an advisory so much quicker than we could in the past. There's going to be challenges as well that we will face. We need to get the lab needs to have the equipment and the training to be able to do this. the expense is really in doing the test at all. And once you've got it, the number of samples you can put in doesn't really make a huge amount of difference. So we're hoping that we can massively increase the number of samples we do with very limited amount of increase in the cost per sample. And that would give us, the square root of n is your friend, as they say. So the more samples we have, the better of a picture we're going to get. So that's what we're looking at. Faster responses, quicker issuing, quicker lifting, and of both advisories and closures in real time almost. So we're going to hand it over for questions now. So Karen, I don't know how you want to do this. I did put in the basis to PCR was to split the DNA. And I did find an actual picture of both Josh and Chad doing that, which comes up on your screen now. I'm not sure which one is which, but maybe we can have some questions.
Yeah, so go ahead. If you're on the Zoom, feel free to unmute yourself and ask those questions.
I have a question. How many, I don't think I caught this part, but how many samples per site were collected for, at one time to compare these results? Was it just one sample per site? Was it, 3 or?
Yeah, each site just got one sample per visit during the collection. We did have to use larger sample bottles and therefore larger sample connection on the pole. So we went to a 1 liter sample collection bottle.
Okay. And another follow-up question, roughly what time were those samples being delivered to the laboratory for analysis?
They would have been delivered within 2 hours to the lab.
Okay, so within 2 hours of collection.
Yeah.
Okay, thank you.
So this is Terry. I have a question. The marvelous thing is that you get, the 90% agreements. The part that I always wonder about is the ICE that you guys created had, an R squared of 0.38, which, was described as good for environmental work, but, not really great for warm and fuzzy. And I'm wondering how much the ICE number that you generated results in variability. And if you had a better ICE, would you have better correlations than you came up with?
I could take that. Well, I would say, if you go through the literature and you look through even epidemiological data, you see people publishing stuff that's down in 0.2 range, and they say that that's significant. So us approaching 0.4 is pretty good. I mean, these are dirty collected samples over a 2-year period from a bunch of different places. So I'm not arguing with you about that. I think you raised a very good point. But I do think this is pretty consistent with what other counties would see when they run a sampling campaign. I'm going to show myself if you want to stare me in the eye, so to speak. Also, in terms of the ICE, we introduced this approach just because we needed something, because, the initial data sets, as Josh showed, is when you have Droplet digital readout of copy numbers per 100 ml to an MPN, they just don't, you're looking at, the Earth and Mars. They're so far apart from each other because the scale, the magnitude is so different. So you really have to put them on the same playing field, so to speak. And that's what our ICE did for our study data. Whether or not a new one could be generated that's even better or more comprehensive, or I guess I should say universal across all of California or all waters, I'm not sure. That's a very interesting question. It could be, but at least with the data set that we derived, that ICE equation was the closest approximation that we could get to scaling the data and putting it into the same, getting it to the same advisory threshold or identifying that from a gene copy number. In the US EPA method, 1609.1, they have a spreadsheet that goes through that conversion step. And there's one step within that equation where they just divide everything by 15. And I never really understood where that value came from. And it probably has to do with some type of correlation between the two. The gene copies are the CSE, which is the calibrated sequence equivalent, to the cell equivalent. So I think that was an attempt of making it universal, but I agree with you. It may not be universal. It might be that in freshwater, it would need to be refined. But I think this provides the first step, or a first step towards generating a tool for that type of comparison.
Yeah, the only thing I'd add is I think this is something, this is something that we did in this study and hasn't been done in this way elsewhere. So it's something that would need to be tested at other sites. It may not be for that number 1413 may not work at every location, and that R-squared number may not be constant either across locations. So it's something we have to test.
Great, thanks for that question. We have Amanda Carr has a question. Amanda, you want to unmute yourself? Go ahead.
Yeah, thanks. And this may be taking us a little far afield. I think this work is great, particularly to address the timing and the information issue. But I guess my perhaps a bigger picture and a very stormwater compliance-based focused question would be, how do you see this work dovetailing or hopefully complementing or addressing concerns about sources of Enterococcus? I know that there have been some concerns about the actual health risk posed or implied by an Enterococcus level on whether or not it's coming from a plant-based source or things like that. Do we think that some of these digital DNA-based methods may help with source identification? And as we're moving towards sort of HF183 and that type of thing, do we see this as moving in that general direction to help identify true potential human health risks?
I can jump in on that. Amanda, thanks for that question. Yeah, I think so. And I think basically how the most straightforward way for that to work is that, again, since we're taking samples and doing a gene-based assay for Enterococcus to understand the beach water quality, adding on another gene target could come along at a relatively easily. There's already assays that are developed. The training for the lab would not require a lot of additional work. Once you're up and running with digital PCR, that's something that could be done, and that would start to, if you used HF183, a human or a human marker that was approved, that would allow you to start making that next level of source identification distinction, that it's definitely a human source, or we don't detect a human source here, even though we have Enterococcus values that are a problem.
Yeah, sorry, I can't speak. In addition to the multiplexing that Josh is talking about, the thing to remember that this Enterococcus, it's an enteric bacteria and it's thermal tolerant. It comes from the human gut. So it had to come, it comes from a mammalian gut. So it has to come from some source where there could be potential contamination. Plant-based sources would be eliminated just because they likely would not grow in terms of thermal tolerant conditions, and the conserved sequences of the ribosomal DNA are pretty consistent. So they're a very reliable target as an alternative indicator in terms of where it's coming from. The source, in terms of the individual source, you would need, as Josh said, their multiplex assay with HF183 if you wanted to identify human.
Great, thanks. Andrew, you have your hand up. Do you have a question?
I do. Can you hear me?
Yes.
I think I should be good. Okay. First off, great presentation. Just amazed by the work that everyone did. Josh, funny you mentioned this 10 years ago. I remember you talking about the Orange County pilot project about this and how that was coming along. So I'm glad to see that this has expanded elsewhere. My question is really geared toward the mechanism of which this method is approved for use. Have you discussed, or has it been discussed whether or not ATP was necessary or needed or required? And not to get into like the administrative burden of that process, but really that can help expand the use of the method elsewhere across the state and really getting that approval from the EPA on that side. And maybe Terry, you're here, maybe you can explore that and how this can really expand method use for this program in general.
Okay, so, I think that we approved it as a pilot program under the Beach Act portion. So we're allowing it to be used for, beach monitoring. I think, to be used elsewhere, we need a few more studies to basically establish that this is not a, one and done kind of thing, right? To establish that, there's consistency at other types of beaches. Then, we could also do it through, Beach Act permission to use this study, or alternately, we can begin to talk about establishing a criterion that would involve the state board. But for right now, we're doing it through the Beach Act. Is that it, Andrew?
Yeah, I think this is a great advancement of use of this technology, and I think Drop Digital is the future, especially in the bacteria realm, and I'm just impressed. And so, to expedite that usage of the method, I think exploring kind of the mechanisms and what needs to get done to really expand the use is warranted, because it's such an exciting kind of advancement. So, congratulations.
Thanks. Kim, do you have a question?
Yes, I do. And I also want to compliment the authors for an excellent presentation and excellent work preceding even the presentation. I think this is all great. And consistent with all the challenges that we've all had, all those of us who've tried to apply more rapid, more reproducible, more economically relevant methods to beach work, I thought I'd let you know that US EPA is actually now in an inter-laboratory test validation process for a multiplex system. We're fortunate to be one of the 16 labs that are participating, because this is relevant not just for beach work, because municipalities and agencies can't be developing specific methods, separate for beach and separate for stormwater and separate for other things. But I think your data is going to be helpful. But I think the sort of effort that EPA is now undertaking, where multiple targets on a standard and standardized for everybody, is really where we're going to have to go. There are people, of course, who have challenges, as you heard somebody else say earlier, relevant to the stormwater issue, that there is some skepticism about the ecological sourcing of enterococci, and so it's better for, I think, all of us if we're using multiplex assays, which I think EPA is now fast tracking, and hopefully by the end of the year we'll get some publication on it. But this is great work. It's exciting. I appreciate you guys. Excellent work.
Thank you.
Thanks.
Yeah, if I could follow up to that, I think ultimately, if we could have just jumped to multiplexing right away, it would have been a great. I think the leap would have been too much for people, even myself. I think comparing a reference standard culture method as an indicator, which everyone has relied on for years and years and years, and then comparing it to a molecular alternative indicator, which is measuring the same thing, the same level of risk. I think people, including myself, needed to digest that first. Many of the publications came out later, including SQUIRPS, and I think that you could target a variety of different things in a multiplex fashion, which is ultimately where this would go. Don't you agree, Josh?
Absolutely. I think that is the one of the next steps, one of the ways forward to make this a more broadly applicable method.
Great, thanks. Eric Dubinsky has a question.
Hi, yeah, great work. Enjoyed the presentation. Just a couple of quick questions. The first is, I'm just wondering, what is the sample throughput for this method? And if you have one machine, how many samples can you do at once?
For us, you could fill up an entire plate with 46 duplicate samples. And that allows for all the necessary controls you would need for for QCing the final data. So it's 46 samples at once. It takes a little bit longer the more samples you have, because you have the Droplet reader portion of it. San Diego, I think, Joseph, on average, they were going to collect 10 to 15 samples per day, which made this much more feasible because it's pretty quick. The processing time is reduced with that number.
So in terms of just once you have a lab set up and you have it dialed in, for an equivalent amount of samples comparing InterAlert to this method, how much extra effort is required to run these tests?
Well, it's I would say so. With InterAlert, it's really sort of you need kind of a lot of hands. The more samples you have. If you have one sample, it's easy. If you have a lot, it takes a lot of time. To get all of those packaged together. The good thing about the PCR-based methods, including Qpcr, is that they're kind of designed to be high throughput, so you can do concurrently many samples being analyzed all at once. So the throughput's a lot faster. But in terms of if you wanted to do a comparison, I'd have to go through the details, but ultimately you get one sample container. As Joseph mentioned, we collected bigger volumes because we wanted to do multiple tests, and then you just kind of split the samples out depending on your test. So I don't really, in terms of feasibility, you can definitely conduct your sample analysis, on this weekly basis. I guess, are you asking, like, are there limitations with the steps?
No, I mean, I'm just, I think there's a perception that these molecular methods are much more challenging and complex than the traditional methods, which I've worked somewhat with these, and I think once you're set up to do it, it becomes more routine. But just kind of thinking through in a practical matter, because a lot of the studies that have been done are research oriented, and ultimately the goal is to have this become more routine. And so just thinking through, what sort of effort is involved ultimately, in running these tests, is just where I was going with that question.
Yeah. I mean, I think the level of effort is, I would say, having done both, I would say that it's probably a little more labor intensive to do the culture methods, but there's a lot of similarities depending on which culture method you're using. You still have to filter water for the molecular method, for the digital PCR. So that's in some ways comparable. But otherwise it's fairly rapid. And once you're trained, I think the throughput does increase at a more, adding extra samples comes at a lower marginal cost for the molecular methods than it does for the culture methods.
Thanks. And just one last question. Is there any disadvantage to using digital droplet PCR relative to Qpcr? I mean, I can only see advantages, with the solving the inhibition problem and also this not having to deal with the standards. And so is there any reason to even entertain, going forward other than, it's a method that's already been established and maybe there's more Qpcr machines out there, but is there a reason to really not go this direction?
I don't see that there's a reason to not go this direction in terms of, what you're going to get out of it in terms of data reporting per sampling effort. You get just so much more out of it. That's from what I see. So,
you do get false positives and false negatives. So there are some, drawbacks to it. But you compare, like the worst case scenario was the 6% false negatives. You compare that to on a 1-day advisory that you're 100% wrong at the current time. So, you're comparing 6% with 100% wrong at that point for a 1-day advisory.
Yeah, and it's you really are measuring apples and bananas. They really are different things in terms of the units, and that's where it's not easy to compare a culture and a molecular method, but ultimately they're serving as an indicator of something that can make people sick, and they both do a great job at that. This PCR has an advantage of it gives you the same day results, so it can warn people early on to not go into a water that has been detected to have a pathogen or potential pathogen in the morning, as opposed to the next day. So I think that's where the big advantage really lies. False positive, false negative rates will always come up, and every method works better where you have a nice signal that falls in a confidence range. Entro alert, I think, was the limiting factor in this study. It's used routinely for AB411 monitoring up and down the California coast, and everyone relies on it for reporting, but it has its own problems. We identified that in our studies. Other published studies, some of which Josh highlighted, demonstrate its limitations. So,
for instance, when you have a sewage spill, any method will work.
Yeah, exactly. Yeah, thanks, Josh. So I think none of them are perfect in an ideal world, I think, but we're stepping towards a more accurate picture using a molecular-based method in terms of indicator presence.
Sure thing.
We have 3 more questions and 3 more minutes.
Yeah, I just wanted to let Sham ask his question. He's had his hand up, probably the last one we can get to. Go ahead, Sham.
Thank you. Amazing work. I was just curious, was there a comparison or a correlation between the nowcast predictive modeling and the results that came out of the study as well? Did you have a chance to look at them side by side?
No, we didn't. We did not input. We don't have a relationship with the people who run nowcast, so
I think that's a good thing to look into, though. Now that it wasn't included in this study, but it would be.
Yeah,
that would be a very cool thing to look at.
It'd be a great follow-up.
Thank you.
There's a couple of questions in the chat, I think.
Yeah. So, Helen, do you want to ask your question? We have 2 more minutes if you want to ask, or if Eric still had some other questions.
Thank you.
Okay, go ahead, Helen.
Thank you. Yeah. So I'm interested in the schedule of the county to include the ddPCR method in the AB411 program. But now I understand that perhaps the state board needs to approve it first, right, in order for you to use it. And the other question is whether when you use it, whether you will use as a cutting off threshold plainly for the coastline. Do you want to use them plainly everywhere, or you will exclude subsegments, like at the mouth of the Tijuana River, where it looks like the agreement is not that good?
Yeah, we hope to use it for the entirety of the shoreline when we do use it. And I'm very impatient to get it going. So we can't use it until the state buy off on it, but we could use it if we are capable, if the lab is up to speed, as an indicator prior to that time. So we wouldn't be able to use it to issue or lift an advisory, but we would be able to use it as one of the indicators of whether there is a spread of a sewage spill. And right now we physically go to a beach, check if there's an odor, check if there's discoloration. Well, it would be nice if we had the capacity to get just in a few hours, get some multiple samples that told us, hey, using a method we know is good, but it hasn't yet checked the box. We know that we now have confidence that there is some data supporting our decision.
Yeah, and the disagreement between some of these sites was really because it was really a limitation of EnterAlert, because EnterAlert was having non-detects or very low positives, and it's likely that the Droplet Digital was picking up treated sewer water that was coming up positive. So there was this dissimilarity between the data points. It still was identifying a risk, though, to that water body. And the 1413 copy numbers for 100 mils, if that is equivalent to the 104 single sample exceedance, those are very conservative values. So, in terms of confidence of whether or not that would avoid illness down the road, I think it would. But I think it needs to be put into practice before. And as Terry brought up, I think, the refinement of that may come up later on with further studies and more data. And that's one of the pitches we put with the study, is that, we're really open to refinements and new approaches that people will use this application.
Thanks, everyone. Thanks, panelists, for your presentation. It was great. Thanks for all your questions. We're going to take a quick break and we'll be back at 11. And if anyone else has additional questions, feel free to email them to the presenters.
Thank you.
Thank you.
Thank you.
All right, welcome back everyone from our break. Next up, we have Andrew Hamilton. Andrew, are you ready?
Yeah, let me do a couple things and share my, oh, let's see if I can start a video. Make me, okay. There. And then, oh, okay, can you just let me know if you see the presentation?
Yes, great, thank you.
Perfect, all right. Well, I'm just going to spend a little bit of time and discuss the quality management system at the water boards. It's just going to be pretty high level, but I wanted to discuss it because it really is going to highlight towards the end of the talk the important work that Kat and Karen are doing to establish a program plan under the Beach Water Quality Monitoring Program. So, okay, just shift space. Oh, there you go. Okay, so before I go, let me give a little update about myself. Because I'm new to the position as State Water Quality Assurance Officer, I'm sure several of you have interacted with the previous Quality Assurance Officer, Renee Spears. I just want to give just a quick update of who I am and a little bit about my background. And just let you know that in general, my role is really as an outsider to ensure that projects and programs are aligned with the Water Board's quality management plan. And so, you know, as we go across that, just think about me as someone that is more of a collaborator, and I'm excited to do so. So I work out of the Sacramento office, and there's the building right there. And I work in the Office of Information Management and Analysis, which is kind of a side division that works, you know, intimately with all the other divisions of the Water Board. My background is I graduated from Virginia Tech with a biology degree. Actually, I was intended to go pre-vet. I was going to be a veterinarian, but I quickly switched because I was really interested in environmental endocrinology. And that pivot took me to California, to Cal State Long Beach, Go Beach. And I got my master's in environmental endocrinology and toxicology, and focused on the stress axis of flatfish in the California ocean, California Bight area. And basically I was looking at the impacts to ocean outfalls to their the stress axis of these fish. Kind of in those interactions and based on my experience in the laboratory and some of the courses I took, I really directed my career towards environmental chemistry, and that's where I started my career in the lab. And so launched into a pretty long career in the laboratory, came back to Cal State Long Beach to get my MBA, and then turned that into a lab directorship or lab director position in Northern California, where I was there for several years, and then decided that I really wanted to help the water boards, and joined ELAP for several years, and eventually got the position as a state quality assurance officer. So that is a little bit about my background, who I am, and what I bring to the table. And here's just some examples of the programs and projects that I've been involved with, and basically the central tenet to my career has been program and project management. Okay, so let me launch into quickly the subject matter of his talk, which is the Water Board's quality management system. So this is a real simple diagram of how we have it structured at the water boards. And really this is in line with how the EPA wants us to establish our quality management system, which starts with a quality management plan, which establishes the overall quality objectives for our agency. And then each individual program plan goes into a little more detail about their specific quality objectives. and how they operate, and then project plans, even greater detail, and incorporating sometimes SOPs. But threaded throughout this is really a quality system that establishes kind of phased approach to how we operate, which is planning, implementation, and assessment. So there is a diagram of our quality management plan. That's my bread and butter. That's basically my baby. One of my major roles at the water boards is to manage and update this document on every 5 years, but I have to review it annually and make sure that we don't need any revisions or changes, and work with management and executive management on what they want to incorporate in this management plan. And really, like I said, it establishes the quality objectives for our agency. If you expand that simple diagram to incorporate the vast list of programs that we have at the water boards, you can see that several programs either have established and developed a program plan, or are in the development stages. And several projects, whether it's statewide projects or regional projects, have also established their project plans, which fall underneath and comply or align with the program plans. And I really wanted to highlight the SWAMP program plan and associated statewide projects and regional projects. That's one of our more established programs at the water boards. And so a lot of the programs and projects now really defer to that. We've got accolades from the EPA on establishing those program and project plans. And so now a lot of our fellow programs are kind of aligning with SWAMP. A lot of the development is mainly because of new programs being established and or programs moving from different agencies. So although they're not fully developed, they're in development, and we're always looking to improve and move forward with that. Okay, so in these program plans and projects plans are established data quality objectives for the program or the project. EPA describes it as a 7-step process to establish these data quality objectives, and you can see the 7 steps are listed there. We've gotten a little more, that's a very rigid approach to this, and we've gotten a little more leniency from the EPA on how we approach it. And the idea is we really want people to answer the questions that need to be answered for that project, starting specifically and most importantly with the question why. Why are you doing this? Why is the program established? Why is the project being established? And launching from there of all the different questions that need to be asked to really establish a systematic planning approach to that program or project. So, going into a little more detail of those questions, these are the type of considerations that are under each major question. And each of them are very, very important and help with the systematic planning. And you can think, I know that in this program, the counties have already established project plans, and these are a lot of the questions that they had to ask when they were providing that QA document. So why do we do this systematic planning? Why is this quality management system established? Essentially, it boils down to is the importance of the data that provided to us at the state or at the water boards, and in the critical decision making that we are burdened or responsible for. And we need to trust the data that we receive or that we get to make those decisions. And ultimately, these planning documents or QA documents and this quality management system is designed to minimize error. And error, it has a major influence on data, and it's complex. It can come in multiple areas, multiple sources, but there's also times where error can be acceptable, and this is where programs or projects will establish their acceptance criteria of what kind of limits are put on the data that's received. All right, so this graphic or this slide is really basic and fundamental, but it's also powerful. If you're looking at this graph on the left, the conclusion would be temperature is going up, and yeah, it's a pretty linear fit, and that can definitely be a conclusion that's drawn. But if you incorporate all the error that may be associated with each of those data points, and if there is no limitation or acceptance criteria, or there is no control of that error, then what you can see is, yeah, those data points may show that the temperature is going up, but when you incorporate that error, in this case showcased by the error bars, you really can't draw that conclusion. It's inconclusive, and there's uncertainty in those data points. And that's what we're trying to control and minimize by establishing these quality assurance documents and systems to make sure that error is accounted for and either accepted or minimized. So this is just an example of sources of error in water quality monitoring. By no means is this like a comprehensive list, but this is just showing you that it comes in different stages of water quality sampling or monitoring, from collection to handling to the actual analysis to the data side, and then even from the data management perspective as well. So since there are many sources, we need to be able to establish standardized approaches to minimize and control those errors, or at least establish the limitations of which those errors can be accepted. So established in each of those plans or quality assurance program plans or project plans are the QC, QA elements to that program or project. And together they are managed to incorporate the idea of continuous improvement. So how we set it up and how it's established based on what the EPA wants us to do, and most quality management systems are established this way. It's a three-phase approach: planning, implementation, and assessment. So all three of those documents, quality management plan, the quality project plan, or the program plans, all incorporate these phases. Also, a very important aspect to any program or project plan is the idea of continuous improvement. And one aspect of continuous improvement is to establish corrective action procedures. And the idea is that it's a real-time auditing effort, where if there's a deviation or if there's something that is outside of the quality objectives, you can quickly establish the root cause and implement changes or controls if necessary, with the objective to prevent problems from reoccurring. And, or establishing a rubric or way to evaluate your processes, and did it work? Did we get what we needed? And one type of way to do that is continuous data reviews. And so for the water boards, all data needs to be reviewed as it's produced, gathered, or collected. We don't delay or wait for that process or that review. And data is always reviewed against the data quality objectives. And the idea is that it's going to inform based on the established quality indicators for that program or project, like accuracy or precision. And so that is our data review process, and that happens whether it is laboratory data, field data, if it's data collected from already established historical data, it needs to be reviewed against the quality objectives that are established. Let's see, and one of the, I'm gonna say new, but one of the great things about being in the agency we are is that we have a open data resolution. So any data that is provided to us must be immediately made public after the review. So once we go through these reviews, it's made public, whether it's a dashboard, a database, etc. we don't hold back on that data. And you can see how important that is when you're considering this program and trying to relay that information to the public in the quickest and most expedited manner. And one of the aspects of the quality management system that we like to really focus on is assessment of the program or project. Towards the end, kind of a big picture review. And the understanding is, in this case, these are questions that would be posed of like a water quality monitoring program. Was enough data collected? Were the right sampling locations chosen? Did we collect samples at the right time? Did we collect what was needed? And some of the questions that were posed in our previous presenters, actually, these are questions that came up. When do you sample? How many samples can you process? Those are the type of big picture review questions that are established in this assessment phase. And if you determine that it doesn't meet the quality objectives, you go back to the planning phase and you start again. So that's kind of really our quality management system quickly explained. But bottom line, what we're trying to do is tweak that thinking of this is how we've always done it to does this meet our needs? Does it meet the needs of the project? Does it meet the needs of the program? And does it align with the quality management plan of the water boards? Or do we need to change? Do we need to modify it? Do we need to update our process? Do we need to establish a new method like our previous presenters discussed? So this is a very important aspect of our quality management system. All right, so what does that really boil down to when we're talking about this program? I kind of put a red box around this. I know Beach Watch is really the data side of things, but it's just easier to fit in that square. So knowing, if you looked at that, let me go back real quick. If you look at that, the counties have established project plans, which is fantastic, but the program plan is in development. And reality was those county project plans were established independent of a program plan. So there really was no reference to the quality objectives that need to be met or aligned with the quality management plan of the water boards. So there's really this gap, right, when that was established. And although that's how it worked, we're moving forward with the help of Karen and Kat and others in the Division of Water Quality. There is a push to develop a program plan that aligns with the Water Board's quality management plan. And those data quality objectives are going to be established for the program, and then we can compare that to the project plans that are established by the counties and see how they align and whether or not they are consistent. So what we might find is that some of these project plans may need to be revised or updated to align with that program plan. And, I will be an individual that will be kind of integral in this process. I'll be helping Kat and Karen and others of the program to review their program plan and make sure that it's consistent and it actually gets reviewed by the EPA and accepted by the EPA. And same goes for the project plan. I'll be an integral person reviewing those to make sure that they're consistent and aligned. So what areas may need to be revised or maybe under review when these once this program plan is established? And really focus is going to be on the data quality objectives. Do they align with what the program is asking for? And are all the data quality indicators from the program or for the program, have they been looked at, or are they established under the project? And same goes for the measurement quality objectives. Do they align with program or are they kind of separate? Something maybe have to be done about the sampling design, frequency of samples, and or are there QC samples that need to be visited based on the program plan needs? And one of the talks or subjects today that Jacob's going to go into next and also was a major focus of the previous talks, was the methods and are they approved for use? And one of my questions was about kind of the regulatory restraints of that, and are there mechanisms to use alternative pest methods? And are we following, or are the counties following that when they do this testing? And then another major aspect that may be discussed, and maybe not initially, but moving forward, is data management strategies, which once you have the data, what are the strategies to get it out to public right away, immediately, up to the EPA and established on the Beach Watch, et cetera. So those are potential areas for review. And with that, I know that was a little longer than I expected actually, but I am here to take any questions. There's my information, and if you don't have questions for me now, please feel free to reach out to me with any questions in the future.
Great, thank you, Andrew. Does anyone have any questions? And we wanted Andrew to introduce himself, since several of you have been working with Renee, and to just reiterate some of the important parts of the QA project plans and to know what's going on behind the scenes. I'll check and see if anyone's emailed me questions. No, I don't see any.
I did a great job of explaining it, I guess.
You knocked it out of the park, Andrew. Do you have anything else you want to mention to people, or any perhaps pitfalls you might have seen in any other project plans that might be helpful to people?
Well, you know, probably the biggest thing to focus on is that this is a collaborative experience. It's not meant to be a do this, do that. We want to collaborate, so we want input in this. And so that goes for the program plan development, as well as kind of aligning and maybe revising those project plans to meet that. If we need to kind of discuss that, that's the process we want to engage in. We don't want this to be you do this and we're dictating how you're doing it. And I don't want it to be fearful that it's going to be a massive change to this program. It's not. It's really just establishing those quality objectives and making sure everyone aligns to it. So it's not going to be like a bowling ball into the pins of the program at all. It's meant to be a collaborative process.
I have a question. So this might pertain to you or Jacob, but it's my understanding that Water Board and a lot of their quality systems will go towards remote auditing of labs. And I want to see how your quality system will manage that, whether it'll be, how you will be able to ensure the quality of a normal accreditation through remote inspections.
Well, that's going to be Jacob. So Jacob, if you want to answer that.
Hey, hi, Chad. Great question.
Good to see you, Jacob.
Yeah, likewise. Yeah, great question. And yeah, you're absolutely right. It does pertain to quality management systems, and that's actually, you know, ELAP has instituted its own quality management system and remote assessments, although not something we had done in the past. Is where we're moving forward to, or where we're at in this time frame, you know, with COVID and all. And so, you know, right now we have a system in place, which involves pre-assessment, you know, gathering documentation ahead of time through the pre-assessment process, reviewing that information and helping our assessors be prepared so that when we do a remote assessment, that we can make sure that we're able to ensure that the laboratory is competent through this virtual setting. So I certainly, you know, it was, like I said, it wasn't something we had really used in the past, but we've now adapted and we're now ready to do these remote assessments as needed. You know, there's also, you know, we're also you know, EPA oversees our ELAP's program as well. And so we're involved with them, and we're having conversations with them, and they're making sure that, you know, what we're doing is compliant or meets the federal needs. Mm-hmm. So yeah, I mean, this is probably a long-winded answer, but for all intents and purposes, you know, our quality management system guides us in how we perform our assessments, and we're ready to do that. I don't know if it will be a long-term thing, if that's how we'll continue to do things. That's still to be determined. But you know, because we have a quality management system in place, like Andrew said, that defines how we will operate our program and ensures quality and continuous improvement, we were able to adapt and be able and move towards remote assessments.
Great, thank you.
Yes.
Yeah, so if no one else has any other questions, and since the presentations are related, Jacob, if you want to go ahead and get started, and then we can combine any other questions at the end for the both of you, if that works.
Sure, no problem. Let me set up the screen sharing here. Okay, I'll now move to the presenter mode. So Karen, can you confirm that you do see it? Okay,
yep,
great.
Perfect, great.
Okay, excellent. So good morning, everybody, and happy St. Patrick's Day. I don't know if anybody had already mentioned that, but I'm sure looking forward to celebrating that later on today, as many of you are as well, I'm sure. My name is Jacob Oaxaca. A little bit about myself: I'm a senior environmental scientist for the California Environmental Laboratory Accreditation Program, or ELAP. I currently serve as a senior technical advisor, and I'm the ELAP liaison for laboratories and state regulatory programs. Over the past 5 years, I've been working to change the landscape of environmental testing here in California by leading the development and implementation of the new ELAP regulations. More recently, I've taken on the role of the designated ELAP officer for California's legislatively mandated Laboratory Technical Advisory Committee. And through that committee, I'm working to address current and emerging environmental monitoring and laboratory accreditation issues. I have a Bachelor of Science degree in chemistry from the University of Texas at Austin. And prior to coming to the State Water Board, I worked in the environmental consulting industry, conducting sampling and project management for environmental remediation and compliance projects. I'm here today for kind of two reasons. First, really to promote ELAP as an advocate for this group here, for the Coastal Beach Water Quality Group. ELAP's mission is to support both regulatory agencies and laboratory needs, and to ensure that the data that is being used for environmental and public health decision-making is reliable for its intended use. So really to that end, and the second point of why I'm here, as Kat Walsh alluded to earlier at the start of this meeting, is the primary purpose is to address the confusion with accreditation of Call Alert 18, specifically for total and fecal coliforms in marine water. And I will provide some recommendations for approaches on how to proceed moving forward. So California ELAP, we accredit over 650 laboratories that are generating data for regulatory purposes. So it's a big number. We're the largest state accreditation program in the nation. And, we just up and down the state, there's laboratories. We have laboratories that are out of state, and even a few in Canada. So we could even say we have international presence as well. Our primary client are the state regulatory agencies. And you can see here on the slide, I've included a set of those. There's not enough space to really show all of the agencies that we service. But many of our stakeholders include the water board programs, other BDOs that are under the Cal EPA umbrella. There's DTSC. We also, service Department of Pesticide Regulations, Department of Public Health, Department of Food and Agriculture. So, a wide spectrum of regulatory agencies that we're supporting. And, we oversee the laboratories, but these laboratories are producing data that is really helping all of the state's environmental stakeholders really to protect, millions of acres of lakes and bays and estuaries, thousands of miles of rivers and streams, and our pristine coastline. Also, drinking water and helping to protect the public water systems. And really, those are all kind of driven by compliance with federal regulations such as the Clean Water Act, the Safe Drinking Water Act, and then also state-specific regulations, policies, and orders. And again, this is not all inclusive. We have some specialty areas that we service, for example, shellfish testing. I didn't quite mention here, but we also, for DTSC, we're accrediting laboratories that are generating data for hazardous waste, for cleanup sites, for enforcement, a lot of different purposes. And so what I'm trying to really do here is communicate that not only is ELAP providing accreditation services, but we also provide scientific and technical support for this wide spectrum of regulatory agencies and also their competing needs. And so to make sense of all this, all of the diverse regulatory objectives that all these agencies have, ELAP looks at the landscape of approved methods through the lens of two primary levels of regulatory authority. So there's the federally regulated parameters, and then there's state regulated parameters. And so you see here on the screen, here on the box to the left, for the federally regulated parameters, the federal regulations such as Clean Water Act, they identify there the approved analytical methods that are allowed for use. Now, Andrew has brought up the need for alternative test procedures when the methods that are approved at the federal level, when a laboratory is going to modify that method, maybe to achieve a better sensitivity or to broaden the scope of what that method is capable of analyzing for. And when that happens, because this is through it's federally regulated, that process then goes through the ATP process. But on the other hand, we have on the box to the right, there's state regulated parameters, and these are just regulated only at the state level. And so for these, the state regulatory agencies, for example, DWQ, they're the ones that are going to decide on which methods ELAP will offer for accreditation. That's why we're here. ELAP offers the methods that are required for regulatory purposes. And as you saw on these previous slides, there's so many different agencies and so many different competing needs and so many different requirements that ELAP it would be impossible for us to understand all of those guiding regulations and requirements. And so it's really upon the state agencies to come to ELAP and say, we need accreditation for this method for this regulatory purpose. And so, going back to here on the state regulated parameters, oftentimes the state regulatory agencies, what they'll do is they'll cite the approved methods that are listed in the federal regulations. And that's, that's their choice, that's their decision. But other times they may decide that there are other methods that they want and that they have approved for use, because these methods have, they're better able to meet the specific regulatory objectives that are, based on the state, at the state level, the regulatory objectives that are at the state level. And, Andrew talked a lot about that, about defining what those regulatory objectives are, defining what the data quality indicators are in the QAPs and in the other quality management documents. So, there's two, like I said, there's two lenses here, and they each kind of have a different path or different routes. So with that being said, that really brings me to why I'm here today, as I mentioned, which is to talk about the confusion over which methods are available for use when testing for total and fecal coliform in marine water. So as many of you are painfully aware, in 2019, ELAP updated its accreditation offerings for marine water to reflect the approved methods that are listed in 40 CFR 136. And this resulted in the removal of Call Alert 18 for total and fecal coliforms. Now, I'm sure many of you are wondering to yourself or asking yourself the question of, well, why for many years was it previously offered? And the best that I can tell, or that I've been able to kind of find out, is that many years ago, there was an unofficial approval from Alexis Strauss and a group working with Squirt. But again, that really wasn't an official approval to use Call Alert 18 in this matrix. And furthermore, there really wasn't any formal documentation that memorialized that decision. And so, and then again, that was years and years ago. And so, fast forward to where we are at now. And when in 2019, when we were updating our accreditation offerings, because of the method update rule from EPA, we determined that in FOA 126, the methods that are offered for marine water, we based on our review, we said, well, these fall under 40 CFR 136. So in that case, we're going to align these offerings with what's listed there. And so now, again, we're in this situation where because of that, the laboratories are fearful, because they're fearful that they're out of compliance for running methods that are not offered for accreditation. And, again, as I mentioned, it's not ELAP, it would be very hard for ELAP to understand all of the underlying regulations and requirements. But from the best that I can tell, this confusion is really stemming from what's possibly conflicting regulatory authority between 40 CFR 136 and what's in Title 17. So this next slide kind of, compares that and takes a closer look at this conflicting authority. So on the box to the left, this is again kind of mirrors that previous slide, where on the box to the left, you have the federal regulation, and on the box to the right, you have the state regulation. So at the federal level, under 40 CFR 136, total coliform by Call Alert 18 is not approved, nor is fecal coliform by Call Alert 18 approved. On the other hand, the federal EPA has approved Call Alert 18 for the analysis of E. coli in marine water. Now looking over here at Title 17, which we know follows what's in 40 CFR 136. And based on the conversations that I've been having with Karen and Kat and her group, what I'm hearing is that for the total and fecal coliform data, that's really primarily used for more of state monitoring objectives, that this data is not being reported to EPA. On the other hand, the Enterococcus data is what is provided to EPA. And so, and that's sufficient to meet the requirements for the grant funding. And so based on kind of that line of thinking, there's this direction to laboratories that go ahead and use Call Alert 18 for total and fecal coliform, which from ELAP's perspective, at a basic level, we see it that it conflicts with 40 CFR 136. And I really want to stress that ELAP will offer accreditation for any method that the regulatory agencies need. It's not our place to tell you what you can and can't use, but in this scenario here where there seems to be this conflict with the federal requirements, ELAP would need explicit direction from the state regulatory agency to kind of override that conflict and be able to offer the accreditation for this method. So in a nutshell, I hope that this kind of really explains kind of the issue and where we're at. And as Kat mentioned, we've been going back and forth and trying to understand where the confusion has stemmed from, and also understand, coordinate on how we can move forward. And you've seen here that there's these regulatory requirements that need to be considered, as well as the cost effectiveness of using Call Alert 18. And so so next, I want to just put out there some recommendations and as for moving forward. And so the first one that I'm going to put out there really is first verifying fit for use. So IDEX cautions the use of Call Alert 18 for total coliform analysis in marine waters without dilution or filtering. And so to address this, laboratories can validate the use of Call Alert 18 and show that the method performance is comparable with other approved methods that are identified already in 40 CFR 136. And I'm sure many of the laboratories here in attendance probably have already done those studies, and they're probably comfortable with making the statement that it is comparable and that it can be used in this marine matrix. And if that's the case, that's good news for DWQ, for the Ocean Monitoring Unit, because then that would give them more of that confidence that they need that this is to use Call Alert 18 for this intended use. So then next, once that's kind of been addressed, the next step or recommendation would be for DWQ to formally request that ELAP offer Call Alert 18 for accreditation in marine waters. And that's again, that's part of our quality management system. We want to have a record showing that why we are offering a certain method or analyte for accreditation, and that really addresses kind of the issue at hand. Previously, we didn't have a process in place to document these types of decisions. And so when the question comes up of, well, why was ELAP offering that in the past? We can't, someone like myself who wasn't there with the program 10, 15 years ago, can't go back and really understand why we were offering what we did. And so to resolve that, this is one way of doing that, is we're asking the regulatory agencies to submit a formal request to ELAP, and so that we can document the regulatory need and then also be able to track how quickly we can turn around and start offering these methods. So there's a lot of purposes and benefits from doing it this way. But alternatively, if DWQ through this process decides that, because of the federal requirements, they may decide, well, it's probably better to work with EPA and try to obtain a statewide ATP to allow for use of Call Alert 18 here in California. Again, that's a decision for DWQ, and ELAP is certainly here to consult and provide our scientific and technical expertise in this area, and to kind of, again, come up with a resolution that is agreeable for all parties involved. But lastly, regardless of whatever approach is taken, there needs to be outreach and education. And I think not only from ELAP to our laboratory community, but in partnership and coordination with DWQ, who is regulating dischargers and anybody else who's required to comply with the Title 17 requirements. So this is my last slide, and I'll just go ahead and leave this up as a starting point for any questions. Again, Andrew's here as well, who is very familiar with this topic. So I think, together we should be able to answer any questions you might have.
Thank you, Jacob. Appreciate it. Does anyone have any questions? I know I've been receiving some emails about this. Joseph, go ahead with your hand raised.
Yeah, as obviously this could play in a pretty distinct role in changing the way that we're operating. We've been using Call Alert 18 as a sample for E. coli as a surrogate for fecal since 2019. So it would obviously massively change things up. Now, we do have some statement or a publication from the state saying it would be equivalent if we used E. coli, Call Alert 18 would be equivalent to fecal MTF, for example. So I just wanted to see what you had to say on that.
I just wanted to step in. Joseph, I think you or someone in San Diego sent me that equivalent document, and it was, I think, from Department of Public Health, from CDPH. It was through another program. Is that correct? It wasn't from the beach monitoring program. Okay.
Yeah.
Do you remember what year that was?
I don't even think it says a year on it.
Okay. I think, yeah, it's a little bit older. So
yeah,
I just wanted to mention that. Jacob, do you have?
Yeah.
Actually, I mean, I've done a little bit of digging, trying to, because this is something that has been an importance for DWQ, and we've been really trying to address this issue. And so it's possible maybe you're referring to a memo from CDPH related to recycled water. I don't know if that's possibly it. That comes to my mind in terms of documents that I've kind of seen out there, but again, nothing that's been really formal, at least from maybe EPA or even from something more recently from DWQ or any of the other regulatory agencies under the Water Board.
Yeah, it's certainly an older document, but we've been using that as a basis to our sampling at the beaches consistently since I think it's at least March of 2020 or 2019. And we used that as the basis for it. We also did a side-by-side analysis of MTF versus MF versus Call Alert, and they were all very much in agreement. So that's what that document called for. I'll see if I can dig it up. I know I've sent it to you before, Karen.
Yeah, I remember. Yeah, and the other thing just to mention is that at least for the beach program, because I don't know if using E. coli for that other program when you received that letter, if that was acceptable, but for the beach program, really shouldn't be using E. coli as a surrogate for fecal coliform. Number one, Title 17 specifically requires fecal coliform be tested. And I know that I've spoken to some grantees about E. coli being a human-specific species of fecal coliform. However, the US EPA has put out studies in their recreational water quality monitoring guides, which then the State Water Board follows, saying that E. coli has been shown to die off in saline waters, which is why we, at least also in the bacteria provisions you all might be familiar with, we recommend using fecal coliform and not E. coli. So as Jacob showed, though E. coli may be an approved analyte for CholAlert 18, it's not the appropriate bacteria to be testing for marine waters. So we are kind of, in a conundrum with that, where we want you to be using fecal coliform, but that analyte isn't approved using CholAlert 18 at this time.
That's not what we found in our study. In a comparative study, we found that the E. coli was an excellent surrogate for the fecal. So
yeah, and I've heard
EPA position.
And I've heard from other counties as well that they have also done side-by-side studies, and they found that everything was equivalent. But I think also from a state board standpoint, we would need to do our own review of the science and put everything together and go through our process before we can formally approve that. And there's many more people than just myself who are involved in saying we're allowed to use one method or another. Diane O'Donoghue from San Francisco, you have a question.
Yes, first, thank you very much for the history lesson there, because we were scratching our heads of how this occurred, because we had been using CholAlert 18 for a long time, and we are now we're no longer using CholAlert 18. We are using CholAlert or InterAlert, and then CholAlert for E. coli, but we are going to fecal, as Karen has stated, for the AB for Title 17. But we just wanted some clarification. Is the validation to use CholAlert 18, would that have to come from the state to ELAP, or can our lab apply for that? And then also, does that verification data go towards then the ATP or
yeah,
accreditation?
Sure. So the approval or the request to add CholAlert 18 to our accreditation offerings would come from the state regulatory agency, in this case DWQ. But that validation study, that would be on the responsibility of the laboratories, and that data could be used by DWQ or other decision makers to help decide whether or not moving forward with CholAlert 18 for total and fecal coliforms is something that that they want ELAP to move forward with. So it's a mix. It's a partnership here, really, between the agencies, the laboratories, and ELAP. We all have our own roles in addressing this issue.
Right. Thank you. Yeah.
This is Andrew Hamilton. I just want to add to that and say that if DWQ wants to, and that's, if it ends up being that an ATP is required, then that actually goes through my office, goes through me. And I'm the liaison from the laboratory to the EPA. They need to have a sign off from the State Water Board that says that this is okay to explore an ATP request. And so if it goes down that route, I'd be involved in that. So just wanted to throw that kind of, not a wrench, but just added layer to it.
Yeah, not really an added layer. Just, again, it's a partnership here, and Andrew is certainly, as the QA officer, is certainly a part of the whole pieces of all this effort.
Yeah, I did get several questions via email. So Elizabeth from County of San Luis Obispo asked, we've been talking about CholAlert 18. What about CholAlert 24, the 24-hour test, or CholAssure, which I know is another brand?
I would probably defer that question to DWQ or others. As far as, again, as far as ELAP is concerned, I mean,
at the request of a regulatory agency, we are ready to offer, any method for accreditation as needed.
Okay, so they're not currently on the list, and do you know if they're on the 40 CFR?
Actually, for that question, I don't know off the top of my head. If they are, it's possible, but it's also possible they don't. I just don't know all of them off the top of my head.
Sure. Oh, yeah. And then I got another email from Gina for Jacob. What is considered comparable since recovery or acceptable? Is it same recovery or acceptable recovery?
And that actually may be a question for Andrew, because, as part of the ATP process, I think that is defined and determined. So Andrew, do you want to comment?
Yeah, so to be comparable with the methods, you actually have to do a fairly robust validation package for the ATP. Whether or not that's going to be something that DWQ requires, I can't speak of, but if you're following the ATP protocol, they actually have one specific to microbiology methods, and so they have a protocol to follow, and essentially you have to demonstrate not only the limits are consistent with the method, with the comparable method. So in this case, it would be I guess either the membrane filtration technique or the multiple tube fermentation technique. And then also that the QC required is comparable, which is a lot of the positive negative controls. And then also the robustness or linearity of it may also come into play. So the other thing I've talked about with the EPA is with this kind of request, you got to consider that it's a statewide, it would be almost a statewide request. So like the previous presenters discussed, they took multiple samples from multiple sites when they were comparing the methods. And some sites were different. They weren't quite as comparable because it's not quite the same water quality. And so it might perform good up in San Diego, but not up in San Francisco Bay, something like that. So you have the EPA will probably ask for a robust sampling and comparison of different matrices. That is something that I would expect from them if it moves forward with an ATP request.
Helen, do you want to ask your question?
Oh, thank you, Karen. Jacob, I have a question for you. Could you please comment on the call alert for freshwater, call alert 18 for freshwater test? For example, are these federal requirements and state requirements in agreement or not? Like you presented the comparison on slide 6, I think. Do you have similar comparisons for the freshwater test? Thank you.
Yes, I have looked at it. I'm trying to recall the evaluation that I did. I mean, I looked at it from the drinking water perspective, from the wastewater. This is the traditional wastewater, like MPDS, the WDR permits, and then ambient water. As far as fresh water, if I can, Helen, I'd like to just maybe say I can get back to you on that. I don't recall it this time.
Sure, thank you. If I can go ahead.
Sorry, this is Andrew Hamilton. I always want to follow up on that. And most of the freshwater ambient monitoring is going to be moving forward consistent with the bacteria provisions that were adopted in 2019. So they'll most likely be monitoring the E. coli and only. And for E. coli in ambient waters, the Colert, Colert 18, and M. coli Blue are acceptable or approved methods for that under 40 CFR 136, which actually sparks a different conversation that I don't know the answer to this, but based on bacteria provisions that were adopted in 2019 by the water boards, the appropriate bacteria indicator for saline waters is Enterococcus. And I was wondering if there's any push to eliminate the monitoring of total coliform and fecal coliform because it doesn't align with the bacteria provisions.
Yeah, so this is Karen Black. So in the bacteria provisions, a total coliform was removed. However, we did retain the fecal coliform requirement because of some public comments that we received. However, as many of you in the audience might be aware, the beach program is actually under Title 17 of the California Code of Regulations versus the bacteria provisions are under Title 23, which is what the State Water Board has its purview over. So when the bacteria provisions were approved, the beach program thresholds listed in Title 17 were not changed. So we have been in discussions with the California Department of Public Health, who has purview over Title 17. And we've, of course, been thinking about this for some time, but we haven't been able to make any changes. But it will be a coordinated effort if that's able to be updated. Sorry, I'm not sure if I answered your entire question there. I just also wanted to mention someone had asked about the integrated report, and I just wanted to make the comment that the integrated report is for compliance with the Clean Water Act. So any data that we do report and analyze for that is going to have to be approved under the 40 CFR 136, those EPA approved methods, not just a state approved method, how Jacob kind of showed the difference. So it looks like we are at the end of our meeting this morning. I want to thank all of the presenters very much for your time and your effort in the work that you do, and all of the participants who came and asked questions and helped with an engaging discussion. Again, we have recorded this meeting, so please sign up for the listservs if you're not already, and we will send out an email when we are able to post the recording of this meeting. And if you have any additional questions on anything, either you can reach out directly to the presenters. We've provided their email addresses on the agenda, or feel free to email me at karen.black@waterboards.ca.gov. Thank you all so much. I hope you have a great rest of your day.